Hello and welcome to this lecture where you are going to learn another technique to evaluate the algorithms. In the last lectures, we were focusing on dividing the dataset into a portion to be used for training and another portion for be used for testing and evaluate the algorithms. For example, 80% of the data to train and 20% of the data to evaluate. But there is another way which is called k-fold cross-validation. We can say that this is the default way to evaluate algorithms. For example, if you intend to publish a scientific paper, you need to use this technique. Let's suppose that we have this data. As we can see, there are 16 instances. We could separate 12 instances to train the data and 4 instances to test. This is the technique we have been using before. Instead of doing this separation, we have this other one here. We separate the data into 4 pieces, and each piece has 4 instances. This is letter K in the name of the technique. K means the number of folds that will be created. In this case, 1, 2, 3, and 4 folds. Then we use these 3 folds with the blue dots to train the algorithm or to generate the probability table, the decision tree, and so on. After the algorithm is trained, we use this other part of the data to evaluate it. In short, instead of splitting the data into only 2 parts, we have 4 parts. According to the K parameter, a common value to be used is 10, so the dataset would be split into 10 parts. We need to get the classification accuracy for this part of the evaluation. Then, we do this other training using the blue dots and evaluate using this other part of the data. After, we use the blue dots to train the algorithm and evaluate using this other part of the data. Finally, we use the 3 first parts of the data to build the model to train the algorithm and the last part to evaluate. As we can see, a classification accuracy will be returned for each one of the evaluations. The advantage of this technique is that we are training the algorithms with all the data that is available. Let's suppose that the first result was 71%, the second result 81%, the third 75, and the last one 70. We add all the values and we divide by the number of folds, which is 4 in this example. The result is 74.25. This is going to be the final result that will be considered to evaluate the algorithm. Instead of having only one value, there are 4 values and we just calculate the average. This is how cross-validation works, and in the next lecture you are going to have a homework, and in the solution we are going to discuss and compare the results of cross-validation and splitting the data into training test and testing set. See you there!